Hello everyone. In this video we're going to go over a review for the exam 1. So the first couple questions are true or false type of questions, and we're going to examine some statements about sinusoidal functions. So the first question says the period of a sinusoidal function is the same as the distance between two adjacent maxima, and this is true. If you take a sinusoidal function, then once that you complete one full turn, then you have repetitions, and you can either check the period by checking the distance between the two maximums or the two minimums. Both of those are going to work out to calculate the period. So this distance or this distance here. Right? Now, question 2 says the amplitude of a sinusoidal function is the distance between the y values of the maxima and the minima. And this is false, because if you take a look here, the amplitude is only measuring this little piece here, or what we would be calling this. So you can think of this more like the amplitude can be the maximum minus the minimum divided by 2. So if this is a normal sine function that goes from 1 to -1, the amplitude of this is 1, and notice that this will be 1 minus -1, which is 2, divided by 2 will be 1. Okay, so in general, the amplitude of general sinusoidal functions will be maximum minus minimum divided by 2. Now, number 3 says the cosine of 3 pi over 2 is equivalent to -1, and this is false. So if you remember, we'll go back again to the unit circle, and in the unit circle, the coordinate x is the cosine of the angle theta, and the y is the sine. So if they're saying cosine of 3 pi half is -1, we're taking the cosine of this point over here. This is pi half, 2 pi half, and 3 pi half, right? But when you see this is the coordinate x, so the coordinate x of this point here is going to be 0. This is going to be the point 0, 1. So cosine of 3 pi half is actually 0. The sine of 3 pi half is -1. Now, question 4 says the radial measure of an angle that measures 120 is 5 pi over 6. So this is a conversion between an angle that is in degrees, and we want to trade that to radians. So to do that, we multiply by the ratio pi over 180 degrees. Since this will transform this angle here in degrees to radians, we get to cancel this here. We get to 12 pi over 18. We can simplify this by 3, and so this will be 4 pi over 6. And if we simplify by 2 again, this will be 2 pi over 3. Okay, so as we can see, this is going to be false. That's not the correct angle. Question number 5 says, suppose that f of t is equals to the sine of 2t. If the function g of t is f of t shifted to the left 3 units. And so we have the expression for g of t. G of t is sine of 2t plus 3. This is false as well, because to have a complete shift, this 2 will have to be multiplying this 3. So instead, to have a chief of the function sine of 2t, we will need sine of 2t minus 3. That will give me a chief of 3 units to the left. And that will be equals to sine of 2t minus 6. Sorry, plus 6, because we're shifting to the left. Now, question 6 says the amplitude of the function y of t equals minus 4 cosine of 3 pi t is minus 4. This is false because the amplitude is a positive value. The amplitude is only measuring distance, so the amplitude here is 4. Cannot be minus 4. Question 7 says the difference between the minimum and maximum values of the function 3 plus sine of 2t is 6. And in this case, this is also going to be false. You can calculate the maximum of this when we get to add the amplitude, and we get to, so the maximum here will be 3 plus 5, which will be the amplitude plus the midline, and the minimum will be the midline minus the amplitude. So it'll be minus 2. So the difference between these values so this is 8, and minus 2 will be 10. So the difference is not 6 but 10. Now question A says the function sine of t is shifted pi units to the right. Then we have the new equation being sine of t minus p. And this is correct. Since we don't have a specific velocity here impacting the sign, just making the minus 5 is going to move the function sine of t units to the right. Now question 9 says the parameter b in the function a plus b sine of c t minus d changes the distance between the maximum and the minimum of the function. And this is true. This is by itself is the amplitude, so this is going to affect the distance between the maximum and the minimum. Actually, by whatever, since we have a middle line here, this is shifted, but still the amplitude tells me how much is the distance from the middle line to the maximum and how much is the distance from the middle line to the minimum. Now let's go for some multiple choice questions. So the first question says a weight is hanging on the end of a spring and is pulled towards the ground and released. As the weight bounces up and down, its height in feet above the ground is given by S of t, where t is the number of seconds since the weight was released. Assuming that no energy is lost to friction, the function s will be sinusoidal. This function is being graphed here, S of t. Now we have that the velocity of the pendulum is also given by the function b of t. We want to know which of the following statement is true. First, the periods of s of t and b of t are the same. B, the period of s of t is half the period of b of t, and the period of s of t is twice the period of b of t. Since the change on movement is also determining how the change in distance is happening and the change in the speed is happening, then the correct answer here is going to be A. The period of S of t and b of t are the same. Notice that according to the movement, then the velocity, which can be thought as the tangent lines, are going to have the same behavior, because this is periodic with a given period here of 4. Then you can see that the speed is also going to behave in the same way and is going to keep the same period. is maybe not going to be the same sinusoidal function, but is going to have the same period nonetheless. Now, question number 2. Question number 2 says the function for sine of 3t minus 6 is f of t. Which of the following graphs is the same as the graph of f of t? And so we have for sine of 3t shifted right through 6 units. The graph of g of t for sine of 3 of t is shifted left 6 units, and 2 units to the right, 2 units to the left. So if you take a look here and you consider the factorization of the 3, you get t minus 2. And so this is going to give you the answer, since you can see that when you factor the speed, you get a t minus 2. So that's going to give me that we're just shifting the whole function to the right 2 units. So answer here is C. Question number 3 says, which equation matches the graph that is drawn here? One of the things that is important to this is you can recognize this by the values that this is going to have. So for example, in 0, this is going to be minus 5. So you should get a function that in 0, first than anything, is not 0. So very quickly, you're going to disregard option C and D, since the sign in 0 is 0. So these two are not going to be true. Now from this one and this one, when you plug in 0, the cosine of 0 is 1. So since this is not going to produce a negative value, the only answer possible is B. Now question 4, it gives me the function y of t equals a sine of bt. So we want to know which equation matches the graph that we have over here, and what are the two parameter values that the graph is going to yield. So we have 3 sine of pi t, 3 sine of 2 pi t, 3 cosine of pi t, and 3 cosine of 2 pi t. Okay. So first thing and then is notice that again we have a function that in 0 starts at 0. So very easily we can see that it's not going to be the cosine. Okay. Since cosine of 0 is going to be 1, and all this is going to become a 0 here, so it's only going to be A or B. But now the amplitude is 3 for both of them. And so you can see that they go from minus 3 to 3. So both of them are good with that. However, then it becomes a matter of the period. So this takes 5 to complete a period. Notice that it goes from 0 to more or less 1.5, which is about to be pi. So the easiest way to check this is, well, the period here is really 2. When you complete the full thing, you go from 0 to 2, you see that you completed a full turnaround of the function. So the period is 2. But on the other hand, the period is going to be also 2 pi over beta. These are the two formulas of the period. This is the formula with the speed in bolding here. So we're going to find that the speed is 2 pi over 2. And so that's going to make it so B is pi. So instead, we can find out that it's not going to be the case of 2 pi t, but the case of pi t. And the answer is A. Now, question number 5 has the function f of t equals a plus b sine of ct. And we know that b is bigger than 0. Which of the following is the difference between maximum and minimum values of f of t? And so we have 2, 2a, 2v, and 2c. So now remember that the maximum is given by a plus b, and the minimum is given by a minus b. Sorry, here. So if you make the difference between maximum and minimum, you're doing the difference between a plus b minus a minus b. So this is going to be a plus b minus a plus b. And so you cancel this and you get 2v. Now in question number 6, we have the same function, but we're asking which of the following is the maximum. And so we know from, we just established this before, this is this a plus b amount. Now finally, to conclude this multiple selection question, we have here a graph function, and for the function that we have graph, we want to pick the interval with the greatest possible rate of change. And so the greatest point of change is where we're going to have, or the changes, rate of change is the points where we have concavity changes. So the changes in concavity, they're occurring here, and they're occurring here, right? They're occurring here as well, and they're occurring here. Those are the points with greatest rate of change. With the great rate of change changes. But and as you can see, that happens because we have changes in concavity. This goes from being concave down to being concave up, then being concave down to being concave up. That's what determines a rate of change that is at the maximum point, possibly at the maximum point. But we're looking for a specifically positive rate of change. So when we're looking for positive rate of change, we're going to find out that this is likely the point and this is likely the point for greatest rate of change. This is a positive rate of change at maximum. Same thing with this one. And this too is a negative a negative maximum, or the greatest negative change. Since we're looking at positive greatest change, or the greatest positive, then we gotta look for this and this. But now when we look at the intervals, I don't have anything closer to 10. I just have something closer to 4. So it's gotta be this interval. If it were the greatest negative, then notice that this is 7, so this one is not going to be. The greatest negative is going to occur between 1 and 1.5. Alright, so that concludes this first part in multiple selection and true and false questions.